Hi, we are Group 14. The team members include Bo Huifang, Yixing Liu, and Chuning Yang. So I'm going to talk about our team project is global temperature analysis. So first of all, what is our motivation? As we know, temperature issues has been of much more people's concern these days, and from the research aspect, we intend to explore the underlying properties of global temperature changing trends. So people should have known that increasing carbon emission in contemporary society are one of the reasons that cause temperatures to be higher. However, some researchers claim that it's natural that the global weather keeps becoming warmer within a relatively short time period, and it has nothing to do with human activities. It'll be very interesting if we dig into this intricate problem. So, a quick view on our data set. The dataset contains years between 1743 to 2013 with more than 200,000 valid data instances, around 49 regions, and more than 3,000 cities. This data is from the Kaggle website, and it has already got 817 upvotes on Kaggle now. So the basic statistics are listed here, and other thing will be mentioned in the dataset section. Okay, so let's go to dataset section, and then in the dataset we have the following attributes: date time, average temperature, uncertainty, city, country, latitude, and longitude. So the data cleaning that we did are not too much. The data was pretty clean. As average temperature is the most important part of the data set, we dropped the rows that has no value for average temperature. So here are some data for these and some possible research questions. For some of them, we already addressed it in our project. For example, are the data consistent from the 18th century to nowadays? And also, can we model the data based on the year, month, or any possible related features? So here are some exploratory analysis of our dataset. So in these two plots, we have plotted the data counts versus the major cities. We can see that Rome and Berlin have the most data points, followed by Kiev and Madrid. In this plot, we have data counts versus countries. We can see that China and India are the countries that have the most data points, followed by Brazil and Turkey. In this plot, we are plotting the average temperature versus available countries in the data set. We can see that the higher the temperature, the darker the color. We can see that the countries around the equator have higher average temperatures, for example, India and Thailand, and the countries that is closer to the two poles have lower average temperature, like Canada and Russia. So we're plotting the average temperature versus the frequency in that the temperature appeared in the data set. We can see that the data is left skewed a lot. So we have much more data that is around 20 to 30 degrees Celsius, rather than the data is around 0 degrees Celsius. Also in the plot on the right, we can see the frequency versus year. We can see that starting from around 1900, we have a consistent amount of data points that is more than 30,000. For years before 1800, there aren't that much data points per year. From the two graphs, these two graphs below, we can see that there are some extreme changes around the year 1800. We're not sure whether they are mistakes in the dataset or the world temperature has experienced a dramatic change during that time. If we look at the average temperature after 1800, we can see that the global average temperature has a tendency to increase with just one big drop after 1880. For this graph below, we are plotting the average temperature of each country with some selected years. The years can be selected, and the temperature will just take the average of these selected years. For example, I can select 2008 and 2007, and we can see that the total average temperature dropped a little bit rather than just selecting 2010. We can see that some countries exhibit very similar trends in the average temperature throughout the year. For example, United States and China exhibit pretty similar trends, while Indonesia and Brazil um, and Philippines exhibit like hot weathers throughout the years. We can see that Chile and Australia appears to have the opposite trend as they are on the other side of the globe, so that makes sense. In this plot below, we are plotting the temperatures in Berlin from 1900 to 2010 by every 10 years, and we're clustering it by each month. So we expect there might be some underlying temperature pattern within some specific month. Surprisingly, we did not find any obvious patterns during these months, so we are going to leave more of this part to our modeling section. Okay, so let's go to our modeling section. So we attempted to find the relationship between the temperature and corresponding geographical and temporal features. We built linear regression models to predict the temperature of a location given the corresponding features. So we are very interested in two specific questions. One, what are the most influential factors of the temperature? Second one, did the annual average temperature gradually increase in the past years? So first, we designed a model to predict the temperature given the special features that are longitude, latitude, and year, month, and day, which are basically all features available in our data set. So here are some metrics that we got from our model. So the above table indicates that the temperature can actually be correctly predicted given longitude, latitude, year, month, and day, as we have a pretty good coefficient and a nice loss. So the coefficient indicates that month and latitude are the most influential factors. For example, the latitude have 0.38 and month has minus 0.95. So another important observation is that the year may not be the most influential feature that has much less coefficient than latitude. So this leads to our second question, that is, can we model can we predict the temperature of a year just given the month and latitude? So here we take the average temperature of Berlin in July, just an example to conduct a case study. So the results indicate that it's hard to predict the temperature of Berlin in a specific month given only the value of the year. The coefficient of the trained model is only 0.0035, which also indicates that there isn't a strong correlation between the temperature and the year information. The below graph further illustrates our findings. So, however, if we take the global average temperature into consideration, we find that there exists a strong correlation between the temperature and the value of year. The coefficient is 0.0035, 0.0083, which is higher than the previous model 0.0035. So this supports our investigation in previous part. So in conclusion, the value of year isn't as informative as other features. It is hard to predict the temperature of a specific city in a specific month. However, there does exist some correlation between the value of the year and the growth of temperature. So further investigation that takes more factors into consideration may give us a deeper understanding of this phenomenon.